For this problem, we're going to take a look at this piecewise defined function where f of x is equal to 4x squared over 1 minus cosine of 3x as long as x is not equal to 0. And it's equal to c if x is equal to 0. And we're supposed to figure out the value of c that makes this continuous at 0. So I notice if I attempt to plug in 0 into this, I would get 1 minus cosine of 0, which is 1. So if I attempt to plug in 0, I would get 1 minus 1 is 0 in the denominator, and that's not a good thing. So I can't do that. Now, there's a couple of choices here. One possible option, which unfortunately does not work, is to try to use the fact that the limit as x approaches 0 of 1 minus cosine of x over x, that is equal to 0. And if I put a 3x there and a 3x down here, that is also equal to 0. So that's one attempt to approach this. And the reason that this doesn't work is the following. So if I try this, so this is not going to work when you say that ahead of time. So this will not work. If I try to do this, then I would have that 4x squared over 1 minus cosine 3x. This would be written as 3x over 1 minus cosine of 3x. And then I would have 4/3 times x. And so this becomes, this fraction here is going to be 1 over 1 minus cosine 3x over 3x times 4/3 x. And so this does not work because, again, this whole thing in green that I'm circling, that is going to 0 as x goes to 0. And so I would again have 1 over 0, and so that will not work in this particular example. Okay, so that does not work. What does work is multiplying by the conjugate. So we multiply by the conjugate. And so let me emphasize, this does not work. So the approach that I have in purple does not work. And so instead, what we'll do is multiply by the conjugate. And so let's take a look at the limit as x approaches 0 of 4x squared over 1 minus cosine of 3x. So that's equal to, and so for the first part, I will just simply copy down what I have on the left-hand side, 4x squared over 1 minus cosine 3x. And now I will multiply by an extra fraction, 1 plus cosine 3x over 1 plus cosine 3x. That's equal to the limit as x approaches 0. On top, I have 4x squared times 1 minus cosine of 3x divided by. On the bottom, this has the form of the difference of two squares. So this has the form of a minus b times a plus b. And we know that a minus b times a plus b, that's equal to a squared plus b squared. And so if I use that, I get that the bottom is going to be 1 squared minus the cosine of 3x quantity squared. And so I get the limit as x approaches 0 of 4x squared times 1 plus the cosine of 3x divided by, okay, now 1 minus cosine squared of something, that's going to be sine squared of the same something. That's one of our trig identities. Okay, now we're getting somewhere because one of the limits that I have in my back pocket is that the limit as x approaches 0 of the sine of x divided by x, that is equal to 1. And I can change this x to 3x, and that limit will still be equal to 1 because 3x goes to 0. Both of those go to 0 at the same rate. And so I will rewrite this limit with the purple fraction in mind here. Limit as x goes to 0. Let me write this as 3x divided by the sine of 3x quantity squared. All right, now what do I do to compensate? So x squared is taken care of. There's a 4 that I'm missing here, so I need to include that. Also, I'm dividing by 3 squared, which is 9. And then I have the extra 1 plus cosine of 3x. Okay, so if the limit as x goes to 0 of sine 3x over 3x equals 1, then if I take the reciprocal, the limit as x goes to 0 of 3x over sine 3x, that's equal to the reciprocal of 1, which is also equal to 1. And so I have that the limit as, well, actually now I'm taking the limit, so I don't need that anymore. This goes to 1 squared. Then I have this is 4/9. And then on this part, I have 1 plus the cosine of 0, which is 1. And so this finally simplifies as 8/9. And so the limit of the limit of x goes to 0 of 4x squared over 1 minus cosine of 3x, that is equal to 8/9. And so therefore, let c be equal to 8/9 to make f of x continuous. And that will fix the whole discontinuity. So I'm not allowed to plug in 0 into this function right here, into this right here, but the limit is equal to 8/9. And so if I go back to the original statement of the problem, find the value of c such that this function is continuous at 0. If this c is equal to 8/9, then the limit as x approaches 0 of f of x will be the limit as x approaches 0 of 4x squared over 1 minus cosine 3x. That is equal to 8/9, and 8/9 is indeed equal to f of 0. And so that would confirm that this function is indeed continuous at x is equal to 0 as long as my c is equal to 8/9.